Hi, I'm Alex. I am a first-year PhD student here at MIT in the EECS department and CSAIL. I am also advised by Professors Omar Khattab and Tim Kraska, and I work very broadly on language models and more specifically where I think language models are underutilized. And today I will be answering some questions that you guys had about my research on recursive language models. You've argued that the language models we already have are much more capable than we've realized. What do you mean by that? So we have some kind of understanding for how good systems like ChatGPT and other language models are. And I think one of the things that I've come to understand or sort of argue is that actually we often underestimate how good these models really are. And I think this really comes from the idea that often the way that we evaluate language models are based on the ways that we think we should be using them. But in some sense, actually, they probably can do a lot more than we give them credit for. And a lot of the limitations actually come from the ways in which we use them and not the inherent capabilities of the models. Cool. So what is a recursive language model, or RLM? And what does recursive actually mean in this context? Recursive language models is kind of the core piece of my current research. And the basic idea is it is a system in which language models call language models, which can call other language models to ultimately provide some kind of final answer after thinking for a very long time. And so within this idea, there are sort of some key components related to giving a language model access to a coding environment and how you actually do this kind of quote-unquote recursive language model calling. And the name recursive comes from the idea that it is a language model sort of calling itself, which can also call itself. And the language model naming of the word RLM comes from the idea that this system itself actually can be thought of as a language model. In some sense, it is sort of taking in some kind of text and giving you some kind of output back as if it is a language model itself. All right. A language model calling another language model isn't new. Neither is having a language model use code. What's the subtle but critical thing your approach does that people have been missing? So this is a very, very important point to kind of talk about. I think generally the idea of a language model calling another language model has existed for some time for the past year. But the RLM paper itself is actually sort of an argument for how exactly such a system should be designed. Kind of the central idea is that the mechanism by which a language model calls another language model exists inside of a code environment. So you can think of it like if you give your language model the ability to write Python, for example, it can call a language model as a function or a module inside of Python itself, rather than the language model using some kind of tool or external API where it calls itself. And this kind of distinction is extremely important because it actually lends itself very well to scale and also to a system that generalizes very well. A core idea in your paper is treating the prompt itself as an environment the model can explore, not just text it reads in one pass. What does that shift in framing actually enable? So one really, really important piece of the RLM paper is that so we think of the RLM as a language model, as I mentioned. And if you're not familiar with this idea, a language model will take in some prompt, like you type in a ChatGPT, like I want you to do this thing for me, and it'll process it and it'll give you an answer. The way that the RLM treats the prompt is actually, it doesn't feed it directly to the language model. And you can imagine this is very interesting, especially for models models that cannot handle a certain length of a prompt. There's always a limit for these kinds of things. So the way that the RLM actually handles this is it stores the prompts inside of a coding environment, and it treats it like something in memory, like a file in memory that it can sort of go through and recursively navigate, and also use the coding environment to try and understand. And so this kind of framing actually allows you to scale your models to handle near infinite contexts, or nearly infinitely long kind of reasoning chains. And this is extremely useful for systems moving forward to get around a lot of the limitations that we've had traditionally in the field. So if I give an RLM 100 videos or a huge code base, it seems to know what's worth looking at and what isn't. How does it do that, and how is it different from what a standard model would do with that same input? Yeah, so you can kind of imagine like if you had hundreds of videos, and let's say you wanted your language or video language model to go through and try and handle this for you. The traditional way that you would do this, or kind of the naive way, is you feed all 100 videos into the model, and you kind of ask it to tell you something about these videos. And as is kind of obvious, it's very, very expensive to do this. Actually, it probably is completely infeasible for most frontier models like OpenAI's or Anthropic's to do this kind of thing. But the kind of RLM way of doing this is the RLM can describe in code, let's say I want to loop through all 100 videos that I have in my computer, and I will call myself and look at each video independently, and write some script to take the output of each of these models and give you some kind of meaningful feedback back. And generally also, one of the nice things that a recursive language model can do is it doesn't actually have to look at all the videos. So if it looks at maybe 5 seconds of each video and it determines that it doesn't need to look at this video at all, it can completely ignore it, which is something that a standard language model is unable to do. A standard language model has to look at the entire video in full in order to understand what to do. Cool. So one of the surprising things about RLMs is that building one doesn't require training a new model or spending hundreds of millions of dollars. What does it actually take? Yeah, so RLMs are this really cool thing because they actually just work with standard and current language models. So you actually can slot in, let's say, your GPT-5 into an RLM-like scaffold, and it will just work out the box. And it doesn't require any additional training to function. Where the training kind of actually comes in is, like most systems, maybe like Claude Code or Codex or things that you've seen, these companies tend to train models to work within these scaffolds. And so one of the really, really exciting things moving forward is seeing whether we can train language models around RLMs and make them extremely efficient and much more capable than they currently are. Can you walk us through a real-world example of a problem that was out of reach before, something that an RLM makes newly tractable? Yeah, so I quite like this question. I think some of the obvious stuff that we've seen in the paper that we put out was that RLMs let you handle basically infinitely long sequences of data, or just you kind of dump in all the information you want, and it can roughly process and give you some kind of thing back. But one of the things that is a little bit more interesting is longer reaching and longer horizon problems. So an example that I like to give is the protein folding problem, which DeepMind had solved, or had given a very good solution to a few years back. And generally the process by which they solved this problem was they had a large team working for a very long time, iterating through many different solutions and many kind of possible ideas and avenues in which they thought this was plausible. And you can imagine that actually an RLM can replicate this process and describe all of this in code. And in some sense, actually, the process by which the team actually solved the problem is not that complicated. You can imagine if you take together a bunch of really smart people and you kind of guide them through what they should do, they can finally solve a problem after a very long time. And RLMs sort of enable these types of problems to be somewhat tractable for language model systems to actually solve. Tell us about your mismanaged geniuses hypothesis. What is the big idea and how does it connect back to RLMs? Yeah, so I think an analogy that I really like to give is that language models themselves can be thought of as geniuses. In some sense, we have spent the last 5 years training these models on all sorts of data and textbooks and things that we have traditionally used to train ourselves to be experts in the fields that we are in. And kind of the way that companies have gone about updating these models is they see this genius and they see that it can't solve a particular task. And the way in which they fix this is by introducing a new genius that maybe can solve a little bit more. And the mismanaged geniuses hypothesis is this idea that actually, if we were to manage these systems better, they actually could solve a much wider range of tasks. And the problem is not replacing a genius with another genius. It's actually figuring out a way to manage how these systems actually work. And one of the kind of takeaways of this whole thing is maybe a language model itself is good enough to actually manage other language models. So with a recursive system making many calls over many steps, how do you keep it on task and prevent errors from compounding? So I think one of the core principles of the RLM idea is that we are deferring all decision-making to the language model. So if a recursive language model call makes mistakes or it hallucinates or things like this, it is the responsibility of the root language model to figure out what to do and verify and help it get back on track. So in some sense, I think a lot of these issues with errors compounding and things of this nature can be solved by the language model that is managing the other language models itself. And this is something that we will likely see through additional training and additional improvements to the actual scaffold itself. Okay, multi-agent systems are having a moment. Where do you see RLMs fitting into that landscape? And what's the first thing you're excited to see people build with this? Yeah, so for context, multi-agent systems are basically having multiple different language model quote-unquote agents or just systems working together to solve a problem. And RLMs are, in some sense, an example of a multi-agent system. But they are sort of an argument for how such systems should actually be designed moving forward. So I think from my view, RLMs are sort of the future direction for multi-agent systems, but I also think that research in this direction is very, very important. And as for what I'm excited for people to build, I think generally it is systems that can think for a very long time. I think one of the more exciting things moving forward is whether or not we can design these language model systems that kind of run forever or run autonomously and can automate a lot more very painstaking tasks like as a research assistant or things of this nature. But yeah, I guess we are out of questions. So thank you all for listening. You can find me on, I guess, any kind of social media, and feel free to ask me any other questions. But thank you for your time today.